In number 25, we want to find use the limit definition to find the derivative at x equal to f prime of 2, where our function is x squared plus 5. So let's remember what the limit definition is. In general, f prime of x is the limit as h goes to 0, f of x plus h minus f of x divided by h. So now we want to calculate this when x is equal to 2. So we have x is equal to 2. So we want to find f prime of 2. So that would be the limit. I'm just substituting 2 for x. So we have f of 2 plus h minus f of 2 over h. Okay, remember f of x is equal to x squared plus 5, so let's calculate these two quantities, f of 2 plus h and f of 2, and we'll substitute it in to this quotient. All right, so first let's do f of 2. That's 2 squared plus 5. Okay, so f of 2 is 9. And now let's look at f of 2 plus h. Okay, here we see f of x is x squared plus 5, so we have 2 plus h squared. That's x squared plus 5. All right, so just square this out. We have 4. Middle term is 4h. The last term is h squared. So that's 9 plus 4h plus h squared. And now we're ready to substitute into this expression. So we have f prime of 2 is the limit as h goes to 0. F of 2 plus h, that's this. Minus f of 2. Now notice this is what I called a 0 over 0 limit. All right, these 9's cancel. And if we substitute h, 0, we're taking the limit as h goes to 0. So if we substitute 0 into this quotient, we get 0 over 0. So this is what I call a 0 over 0 limit. So we can't evaluate this until we do some canceling from numerator and denominator, and we can cancel an h from the numerator and denominator, or equivalently divide h into the numerator. So let's do that. H divides into 4h and h squared. So this is equal to, let me just scroll up. The limit as h goes to 0 of 4 dividing by h over here. So we have 4 plus h. And as h goes to 0, well, that goes to 0, so we just get 4. So this is equal to f prime of 2. This is the slope. Oops, I mixed up my letters over there. Okay, let me rewrite that. This is the slope of the tangent line. To f of x at x equal 2. So you see in the next part of this question, we want to find the equation of the tangent line to f of x at x equal 2. Okay, so let's look at that. Let's look at part B. We have the slope. So now we want the equation. So we want the tangent line to f of x equal x squared plus 5 at x equal 2. Well, we need a point in the slope. We have the slope. We just figured out that the slope is 4. Okay, so we need a point. Well, the x-coordinate of the point is 2. And to get the y-coordinate of the point, we just substitute in into x squared plus 5. So we did that in part A. That's 4 plus 5, that's 9. All right, so we have a slope and then we have a point, so we can easily get the equation of the line. All right, we can use, let's say we use y equal mx plus b. So the slope is 4. So we have y equal 4x plus b. And now we have to figure out b. Use the point to figure out b. Substitute a 2 for x and a 9 for y. Here we have 4 times 2. That's 8. Okay, we put a 2 in here. Okay, so we have 4 times 2, that's 8, plus b. Subtract 8 from both sides, and we have b is equal to 1. So our line, our tangent line, is given by y is equal to 4x plus 1. In number 26, we want to use the definition of the derivative to find the derivative f prime of x for this function. F of x equal x squared minus 2x plus 3. We'll start by writing down the definition. Okay, let's calculate f of x plus h over here separately, and then we'll substitute it in. So we're substituting x plus h for x. So here we have x plus h squared minus 2 times x plus h plus 3. Okay, so we get, squaring this out, we have x squared plus 2hx for the middle term plus h squared minus 2x minus 2h plus 3. Okay, we can't simplify this or combine. There are no like terms. All right, so we'll just take this expression exactly as is. And we're going to substitute it right here. All right, so now we have f prime of x is equal to limit h goes to 0. This expression that entire expression. And now we have to subtract f of x. So minus, and in parentheses we have x squared minus 2x plus 3. Just be careful with the signs. Okay, so now we're ready to open parentheses over there. Let's do that. So this is limit h goes to 0. So here we have, again, I'm copying over x squared plus 2hx plus h squared minus 2x minus 2h plus 3 minus x squared, opening parentheses, minus x squared plus 2x minus 3. All right, now we have quite a bit of canceling. We have x squared canceling with minus x squared, minus 2x canceling with 2x, and plus 3 canceling with minus 3. So here's what's left. 3 terms left. Okay, so let's put that in the quotient. 2hx plus h squared minus 2h over h. All right, this is again a 0 over 0 limit. If we substitute in the value that we're approaching, which is 0, we get 0 over 0. So we have to do some canceling, and we can divide h into the numerator, or we can cancel h from top and bottom. So let's do that. So we have the limit as h goes to 0. And here we divide by h, and we have 2x plus h minus 2. And now we're ready to take the limit as h goes to 0. So just this term goes to 0. And we end up with 2x minus 2. So that's equal to f prime of x. In 26b, we want to find where the tangent line to the same function is horizontal. Okay, so remember that the horizontal line. So now we're doing part B. Okay. Remember that the horizontal line has slope 0. Now this f prime of x, it is a function, you can think of it as a function whose values are slopes. So we want to know, when is this function equal to 0? So we just set this derivative, or think of it as a slope function, equal to 0 and solve. So we have 2x equals 2. Divide by 2, x is equal to 1. So the tangent line is horizontal at x equal to 1, or at point 1 comma, and what do? We substitute back into the original function, into x squared minus 2x plus 3. So that's 1 minus 2 plus 3. Okay, or that's the point 1 comma, this is minus 1 plus 3, so that would be 2 at point 1, 2. In number 27, we want to use the alternate definition of the derivative. So let me write that down. F prime of c is equal to limit x goes to c, f of x minus f of c over x minus c. To find, we want to find f prime of 4, where f of x is 1 over the square root of x. Okay, so in our case, c is equal to 4. So let's do, let's substitute in c is equal to 4. So we want the limit as x goes to 4, and f of x is 1 over the square root of x, minus f of 4, that's 1 over the square root of 4, x minus c, or x minus 4. Now notice this is a 0 over 0 limit. Substitute in x equals 4, and we get 0 on top and 0 on the bottom. All right, so we have to do some manipulating. This 1 over the square root of 4, what's that equal to? That's 1/2. All right, so we have the limit as x goes to 4, x minus 4, and here we have 1 over the square root of x minus 1/2. Okay, so let me just erase some of this. Okay, so we can multiply top and bottom by the conjugate over here, the conjugate of the numerator. We often do that type of thing when we want to manipulate an expression involving the sum of a square root. Okay, so there's the conjugate. Okay, so let's do that. Remember, the middle term drops out. So we have the limit x goes to 4. In the denominator, we'll just write x minus 4 times 1 over square root of x plus a half. In the numerator, the first times the first is 1 over x, and the last times the last, that's minus 1/4. And remember, the middle term is 0. Now I still don't see an x minus 4 in the numerator, but if we combine 1 over x minus 1/4, just add those two fractions, we'll get our x minus 4. Okay, so here, common denominator is 4x. Multiply top and bottom here by 4, and top and bottom here by x. And there we have 4 minus x and x minus 4. So we can cancel these, replacing with a minus 1, because this is a subtraction in the opposite order. So finally we can take the limit by substituting in x equals 4. This is no longer a 0 over 0 limit. So here we have minus 1 over 4 times 4 minus 1 over 16. And in the denominator we have 1 over the square root of 4, which is 1/2, 1/2 plus 1/2, which is 1. Okay, so that's just equal to minus 1 over 16. So we see f prime of 4 is equal to minus 1 over 16.